I also want to mention something else that comes up a lot with exponential functions and exponential graphs is this idea of a linear scale versus a logarithmic scale. So what I have here are some examples of actually the same data, but presented differently based on the scale. So the linear scale is probably what you're most used to, which is that we're looking at the y-axis and the increase from one tally to or line to the next is the same. So here, this is like in 5 millions. So it's like there's 5 here, and then it increases by 5, it increases by 5 again. So there's a consistent increase as you go up on the y values. So that's what it means to have a linear scale. So again, the one that's most commonly used. A logarithmic scale changes. And it goes up, it multiplies by a constant as you go up on the y value. If we multiply it by 100, instead of just increasing by 100, for example, then we would get to 10,000. We could multiply by 100 again, and then it's up to 1 million. And the reason that one might do this is because sometimes when we're looking at exponential growth, since it happens so rapidly, it's kind of hard to tell like the nuances or what are some of the smaller changes and what are the changes that are happening instead of it just shooting up. But I think it's just good to note that if you are looking at a graph, that you recognize what the scale of the y-axis is, and then that can help you interpret the data that you're given. I also have another graph down here, which is basically the same thing. It's the exact same data. It's just one is presented with the traditional linear scale, and another is presented with the logarithmic scale.